The objective of this video is to practice drawing Bode plots and using the graphical operational techniques that we've discussed in our introductory videos for this unit and that we've been using to build up progressively more complicated Bode plots and graphically depict more complicated transfer functions. So we're going to work through a series of exercises. There's no new theory presented in this video. It is simply a series of exercises to help you get more familiarity with this concept. So our first exercise, I've sketched the Bode plot of the magnitude of two transfer functions, a transfer function A and a transfer function B. I want you to draw for me a graph of A multiplied by B in decibels. Press pause now and press play when you're ready to resume. So we know that when two transfer functions are multiplied by each other, the decibel graph has this graphical relationship. That is, you sum the two transfer functions. So we can easily sketch this on our plots up above because we're taking a constant 20 decibel line. So A is always 20 decibels, and then B is as depicted where it starts at 0 decibels. So going from left to right, if we start at 20 plus 0 decibels, we're up at the 20 decibel line. I'll sketch this as a highlighted text. We start at 20 decibels, and at 10 kilohertz, B starts to go down at a rate of negative 20 decibels per decade, while A remains constant. So we subtract off 20 decibels per decade at starting at 10 kilohertz, going onwards. So we're left with next, I've given you two transfer functions, function C and function D. And the decibel plot of function C is at a constant 30 decibels, while the decibel plot of function D starts off at 20 decibels. At 1 kilohertz, it starts increasing, and at 10 kilohertz, it stops increasing and remains fixed at 40 decibels as omega goes to infinity. I want you to draw the decibel plot of C in parallel with D. Press pause now and press play when you're ready to resume. So we know that the parallel operation of two transfer functions in decibels is approximately equal to taking the minimum of the two transfer functions. And we can sketch this on this plot by starting with the minimum of the two transfer functions, which is transfer function D. And then at this point right here, the minimum becomes transfer function C. In our third exercise, I have again drawn two transfer functions. Transfer function T, which is constantly sloping down at negative 20 decibels per decade, and transfer function E, which starts out at a constant magnitude, then at 1 hertz increases at a slope of 20 decibels per decade. At 20 hertz, it remains constant until we get to 400 hertz, and then it starts decaying at negative 20 decibels per decade. And the problem here is a little bit different. We're saying that T is equal to the product of two transfer functions, E and F. We've given you E, but I want you to calculate F. Not numerically, but I want you to draw what F looks like on this plot. Press pause now and press play when you are ready to resume. So the divide operation, F is equal to T divided by E, is equal to a subtract operation in the decibel plot domain. So we say that the transfer function F in decibels is going to be T in decibels minus E in decibels. So now plot this on here. And starting at the rightmost position, we can see that that T minus E in this regime is going to be a constant value that's negative. So I'm just plotting on here T minus E. And actually, let me label. So we start off in our constant region, and at 400 hertz, E becomes a constant value while T continues to increase. So we'll see F increasing, and we should draw one more frequency point here, which is where T and E intersect. So E is increasing in this region at a rate of 20 decibels per decade. And again, at any given point, the value of F is T minus E. And then, at this point, F starts increasing at a rate of 40 decibels per decade. And finally, we resume increasing at 20 decibels per decade. So that concludes this set of exercises. We're just practicing using the operative transformations that we defined a few lectures ago and getting some practice using the graphical techniques.